If you're gearing up for the Certified Architect exam, or if you just want to truly master autonomous AI, you're exactly where you need to be. Making that leap from building basic chat apps to engineering fully autonomous agents, it's usually the biggest hurdle for developers. And frankly, it's the #1 stumbling block on the Architect exam. So we're going to get incredibly technical today. We're looking at exactly how to build reliable, scalable agents right from the ground up.
Okay, let's take a quick look at the agenda. 1. Chat versus AI agents. 2. Defining the 3 roles. 3. Inside the agentic loop. 4. Understanding the stop reason. And finally, 5. Agentic loop anti-patterns. Let's jump right in.
Section 1. Chat versus AI agents, the paradigm shift. We really need to start with the fundamental difference between standard prompting and true autonomous action.
The LLM is the brain of the agent, and the tools are the hands. I mean, that really hits the nail on the head, right? Think about a standard chat model. It's essentially a brain in a jar. It just sits there, thinks, and talks. You give it text, it gives you text back based purely on its training data. If you ask that standard model for a live flight price, what happens? It's either going to hallucinate a number or politely apologize because it has literally no way to interact with the current world. But an agent actually has hands. When you integrate tools, you're giving that brain the ability to reach out into the real world. It can query live databases, manipulate files, take tangible action. It's not just guessing an answer, it's going out and finding it.
The contrast in the architecture here is just massive. Imagine asking a standard chat interface to book a flight from India to Australia. Best case scenario, it hands you a nice text template for an itinerary or tells you to go check an airline website. It's a very simple, single-turn, back-and-forth interaction. But an agent operates on a continuous, autonomous loop. You give an agent that exact same query, and Claude steps up as the reasoning engine. It observes the request, autonomously decides to use its live pricing tool, picks out the cheapest tier, feeds your passport data into a booking function, and executes the actual transaction. It literally keeps working, reading the responses from all those tools and tweaking its strategy until that flight is actually booked.
Section 2. Defining the 3 roles. Rules of engagement. Now, before we look at the actual code execution for these loops, we have to establish the strict cast of characters interacting within the Claude SDK. You see, every single message passed to the Claude API has to be strictly tagged with one of 3 roles. First up, this system role. This is your who you are prompt. You usually inject this once at the very start of the session. It's like telling Claude, hey, you are a top-class social media marketer. Then we have the user role. That's the human, us, sending in a query like, generate a campaign for ginger tea. And finally, the assistant role, which is the LLM itself, processing the query and sending back its response. And listen, these are not just abstract concepts. They are literal required JSON keys in your API payload array. If you mistag a role or, put them in the wrong sequence in your code, the API isn't just going to magically figure it out. Nope, it will instantly throw a 400 bad request validation error. Your code has to manage these roles perfectly. And that brings us to a crucial architectural reality. The Claude API is 100% stateless. You can basically think of Claude as having the memory of a goldfish between API calls. Total amnesia. If you say, my name is Akash in one call, and then ask, what is my name in the very next call without providing that previous context, it'll have absolutely no idea. You have to continually append the full history of those system, user, and assistant messages into an array, and send that entire ever-growing conversation block back to the server every single time you hit the API. So as your agentic loop spins, your payload gets heavier and heavier. Managing this context window efficiently is a massive part of your application architecture, and quite frankly, it's a huge factor in managing your AWS or API bill.
Section 3. Inside the agentic loop, the engine at work. Let's move over to the actual code execution, where the brain and the hands truly connect. Imagine an end user typing into your app, where is my order 4821? Obviously, Claude doesn't just guess the answer, and it certainly doesn't have your company's proprietary database memorized. Instead, it enters this cyclical engine, the agentic loop. Now, in your application code, this is literally a while loop that does not terminate until the LLM gives it permission. The model checks the tools you've provided, figures out it needs to use your custom order lookup tool, waits for the result, and continues reasoning on that fresh data until it can finally answer the user's question with absolute certainty.
Let's walk through this exact back-and-forth dance as it happens in your code step by step. Step 1. You send the initial API call with the user's message and a JSON array of all the available tools. Step 2. Claude's brain realizes it needs live data, so it pauses its text generation and requests a tool. Now, step 3, and pay close attention here, because this is probably the biggest misconception developers have. Claude does not run the tool. Your local environment runs it. Claude just outputs a JSON block saying, hey, I want to run this specific tool with these specific parameters. Your custom Python or Node code is what actually queries the database. Step 4. Your code gets the result. Let's say the order status is shipped, and you append that result back to the message history tagged as the user role since it's new data coming from your side. And finally, step 5. Claude reasons again based on that newly injected data.
Section 4. Understanding the stop reason, the decider. So how does this continuous loop actually know when to pause to use a tool or when it's finished entirely?
This brings us to what is easily the most important technical concept for your architecture, the stop reason. Every single time the Claude API returns a response in this cycle, it provides a strictly defined flag in the response metadata called the stop reason. It is absolutely vital to understand that this isn't conversational text generated by the model. It's a specific programmatic string embedded right in the API response payload. Think of it as a hard flag acting as a signal to tell your application code exactly what it needs to do next.
This is the critical binary concept you've got to master for the exam. If the stop reason comes back as tool use, it means Claude wants to act. Your code has to pause, extract the tool parameters Claude requested, execute that tool locally, append the results to your message array, and fire it all back to Claude to continue the loop. But if the stop reason is end turn, Claude has completely finished the task. It's got the final answer. So your code should break the while loop, extract the final text, and present it to the user. What happens if your code messes this up? Well, if Claude says tool use and your application accidentally treats it as end turn, your end user isn't going to see a nice conversational answer. They're just going to get blasted with a raw, ugly JSON tool call request right on their screen. So remember, tool use means keep spinning the loop. End turn means you're done. Section 5. Agentic Loop Anti-Patterns. How to not crash. Let's look at the architectural pitfalls that will crash your custom agent and definitely cost you points on the certification exam.
These are the 3 deadly sins of agent building. First, never try to parse Claude's natural language for an exit command. Claude's phrasing dynamically changes. If you use regex to check if Claude said, I am done, sure, it might work twice during your testing, but at 3 a.m. on a Sunday, Claude's going to decide to say task complete instead, and your application will crash with a fatal index error. Second, while you absolutely should use an iteration cap, like a 50-loop limit, as a safety valve so a runaway loop doesn't drain 10,000 API credits in 10 minutes, you should never use it as the primary way to exit your logic. And third, never check content types. Just because Claude returned a structured JSON object, that does not automatically mean the loop is over.
So, to summarize these best practices, your code architecture should be entirely model-driven. Avoid rigid regex checks or manual sequence hardcoding at all costs. The only thing dictating whether your loop continues or breaks should be that exact stop_reason flag returning from the API. Your custom code is just the vehicle. The stop reason is the steering wheel. You've got to let the LLM's brain do the driving.
We've broken down the stateless nature of the API, mapped out the strict JSON roles, and engineered the core while loop driven entirely by stop reasons. You now have the architectural blueprint to connect the LLM brain to highly functional hands. We've given the brain its hands. So now the question isn't really whether AI can act autonomously, it's what are you going to build with those hands? Will you automate a tedious internal workflow, or are you going to revolutionize an entire industry? The blueprint is yours. Happy building.